Hello, can you hear me?
Yes,
Yes, ma'am.
ma'am.
Okay, you can hear me.
Yes, ma'am.
So there was some problem with the laptop. No issue. Now it is okay. Sorry for the delay. So yesterday we have seen about the properties of matter. So now one by one, can you tell? Ria, first property. Ria, can you tell the first property? Ria, can you hear me? Aditya,
Ma'am, not able to hear.
what? Aditya, can you hear me?
Yes, ma'am.
Yeah, can you tell the first property?
Matter is made up of tiny particles.
Matter is made up of small tiny particles, right? Amrita, second property.
The particles of matter have space between.
Particles of matter has space between them. Okay, right? Tanya, third property.
Particles of matter are never at rest and they continuously move in all directions.
Yeah, particles of the matter are not at rest. They are continuously moving in all random directions. Then next, Ankita, fourth property.
Particles of matter uh, particles of matter have force of attraction between them.
Okay, right. Very good. So four properties you have to remember. This question can be asked for 2 marks. What is matter? Or define matter and write properties of matter. Okay. So these question will be. Now next part is the classification of matter. So matter is classified into two ways. It get classified. It is according to physical properties and according to its chemical properties. So matter we can classify. Sorry. So matter
No.
gets divided into two ways. First, according to physical properties, and the second according to chemical properties. Physical properties, that is depending on its physical appearance. So how we can see any object depends on that the matter is divided. So according to physical properties or physical appearance, external appearance, we see the matter is divided into three types. Those are solids, liquids, and gases. Okay. And according to chemical properties, that means in terms of the types of particles. In terms of chemical properties means the particles, structure of particles, types of particles present in it. It's divided into again three types. Those will be elements, compounds, and mixtures. So according to chemical properties, that means if we see the different types of particles present in it, if we divide matter in according to that way, then it is divided into elements, compounds, and mixtures. And if you see only the external appearance, that is how it looks like from outside. So that way, according to its physical properties, we divide matter into three types, which we call as solids, liquids, and gases. So in this chapter, the chapter 1, matter in our surrounding, we are seeing the structure of classification of matter according to physical properties, that is solid, liquid, and gases. And in the next chapter, that is in the second chapter, we are seeing the classification of matter according to chemical properties, that is elements, compounds, and mixtures. It's clear? So we are starting with the physical properties, studying the properties of solids, liquids, and gases. So which substance we call as a solid? You have learned this. This is a very basic part. So we are
substance in which the molecules or the atoms are tightly packed.
okay. The particles are tightly packed. So the matter, type of matter in which the particles are compactly packed, so they retain their shape. So that means this the type of a matter in which has definite shape and definite volume. So they are considered under solids. They have definite shape. That is a main important point. Then now you will say that is they have definite shape. That means the sugar don't have definite shape. Is it yes or no? Sugar have definite shape or not?
Yes, ma'am.
Sugar, yes. So sugar means you are considering the full more amount of sugar. So that is not the crystal. One crystal of sugar if you consider, then that crystal of a sugar has a definite shape or not? It has a particular shape.
Yes.
If we, without hammer, can it retain that shape? Without hammering, does it retain its shape or not?
Yes.
So is the same thing happen with the salt crystal also? Will it maintain its shape or size or not? Does it maintain proper shape?
Yes, it maintains proportion.
So that means the solid are the types of matter which retain their shape and they have definite volume. Then what about liquids then? Liquids do not have their original shape, means it's a proper shape. Their own shape they don't have. They, when they are poured, they will take the shape of the container. So those are liquids. But they have one more extra property they possess, that is they have definite volume. So when you pour water into from one container to another container, they always take the place of the bottom of the container. So, and their volume always remain constant. If you take 1 liter of water, after pouring into the some other container, does the volume changes? Will that 1 liter will become 2 liters? Is it possible?
No, ma'am.
No. So that means the volume of the liquid always remain constant, right? Now what about the gases? Now gases also don't have definite shape. They don't have proper shape. They, you know, whatever the container you are pouring, it will take the shape of that container. And one other differentiating point is it don't have definite volume. So if a gas present in a 1 liter container, if you pour into the 2 liter container, what will happen? What will happen in that?
Its volume will change.
Its volume will change. It will take the full space of that 2 liter container. So in that case, we will write, we will tell that the volume of the gas is now 2 liters because it is present everywhere in that container. So therefore, the solid and liquid difference is its shape. So solid has definite shape, liquid don't have definite shape. But they have same equal volume. They have the same volume, definite volume. The volume won't change, whatever it is initially. In case of liquid and gases, what is the difference? They have the same shape. Shape is not definite, but they will take the shape of the container, both of them. Now, what is the differentiating point between them is the volume. The liquids have definite volume, but the gases do not have definite volume. It's clear. So these are the main 3 differentiating points. So there are many more. All other properties also we have to take as a differentiating point. So we will see. So instead of studying all the properties separately, we will study as a comparison point. So you can see the structure of solid molecules. The particles of solid are compactly packed. You can see here the solid structure. The particles are packed very compactly, very less space present between them. 557652. 7652. हाँ मेरे इसमें देखो ग्रुप में किस ग्रुप में डालिए केवी में है ही okay. So and then liquid, you can see they are able to move. They have the spaces between them is more space between the particles. And the gas, number of particles are very less and much more space between them. Space in gaseous particles is much more. Now you are only telling me the differentiating points. I have written the properties one by one. You are telling me. Ankita, first, what about the masses? About the solid, liquid, and gas. If you see the mass of a solid, in terms of definite, indefinite, you can write. So I'm not asking the exact mass. I'm asking it whether it has definite mass or do not have mass.
Solid has a definite mass.
Okay, solid has a definite mass. I will write it down in 1 second. Yeah,
Liquid also has a definite mass.
yes, right.
And gases have indefinite mass.
Mass, indefinite. Mass will change. Number of particles are changing.
No, definite.
It is a matter. That means every matter has a definite mass. That is a property of the matter. This one, definition of the matter we already have seen. Everything should possess mass and they have definite mass.
Okay, ma'am.
Okay. Then shape. Amrita, can you tell about the shape?
Shape as definite.
Definite shape for, okay. Solid has definite shape. What about liquid?
Definite.
They have the proper shape.
And they keep on changing indefinite.
Indefinite. That means indefinite shape. That is, they take indefinite. Sorry. That means that is, they take the shape of the container in which they are poured. Okay. Then what about the gases?
Definite.
Definite gases have definite shape. Gases, gas when you keep it in a container, it will have the definite shape. The gas,
Indefinite.
oxygen, this one's shape remains same.
No, I'm indefinite.
Indefinite shape. And they will take the shape of the container in which it is poured. Then next, Pranjal, volume.
It has definite volume.
Okay.
Liquid has indefinite volume.
Liquid has indefinite volume. Volume of the water, 1 liter of a water, if you pour into the another container, the volume will change. 1 liter will change to 2 liters.
No, ma'am.
Then
It'll be definite.
definite.
And gases have indefinite.
Gases have indefinite volume. They don't have definite. They will take the full, occupy full space. You can write here. Gases occupy all the space of the container. Okay, so whatever the space is available to them, they will occupy everything. That is not happen that is air moves in our room and it is only present in a one corner. It is not present in the other corner. Does that happen? Is it possible? That is the air rushed in our home house and it is present only in a one room. It is not present in the other room. Is it possible?
No,
Trishna, is it possible?
No.
No, it is not possible. That means it will occupy full space present to it. Okay, this one possible to it. Then what about rigidity? Anurag is there?
Yes, ma'am.
Yeah, Anurag. What about
Ma'am,
rigidity
ma'am,
means?
solid is rigid.
Rigid means what?
Ma'am, it's strong
Strength.
or a particular shape.
Maintaining the property of maintaining their particular shape. So hardness we can consider. Okay.
Yes,
Solids are
rigid.
rigid. Okay. What about
Ma'am,
liquid?
liquid are not rigid.
They are non-rigid. So that means they are fluids. They are able to, they are not able to maintain their shape. So they are called fluids.
And gases are also non-rigid.
Non-rigid. That is, they are fluids. Fluid means can flow. Fluid means which can flow are called fluids. Though liquid and gases both are fluids. So they can flow. They do not retain their shape. Then next, Vishal, compressibility. Vishal, Compressibility. What is compressibility means? Yes, Vishal. Mic is not working. Hanif, can you tell? Hanif, can you hear me? Unmute your mic now and tell the answer. No. Okay. Yes, Hanif. Yes, Hanif. Can you tell about the compressibility? No, I'm not getting your voice. Mm, clear. Okay, I will come back to you again. Pranjal, can you tell? What do you mean by compressibility?
It means that if an object is compressible, it means that uh, we can
Yes, right. Yes, yes. You're supposed to tell that. Squeeze.
yeah
Okay, so compressibility means squeezing. Can we squeeze it or press it?
we
Solid
cannot. For solid, we cannot.
cannot. So it is incompressible. Liquids,
No.
it is actually almost incompressible. At some extent, that is 0.01%, yes.
Okay.
So it is, I will explain you how. Almost incompressible. I will write first.
Yes.
So compressibility means the pressing, squeezing it to convert into the smallest space possible occupying. So solids, no, it is completely, we cannot press them. Is it possible that is press the pen and it will become shorter in size? Is it happening?
No.
No, that is not possible. What about the liquid? So for this, in your textbook, it is given one activity, that is take a injection piston, you know, injections with which it is given. So that is a one example of piston that we call as piston. In that, you have to take out the cylinder backside, that this press with which we press, we have to take it out, and we have to fill three syringes we have to take. In three syringes, one you have to add sand. Second one you have to add any water, and the third one you have to add air in it. But the other side, it should not be open. It should be closed from the other end. So in that case, what happens when we start now pressing? So that is backside portion we have to add, and we have to start pressing it. Is it possible to press the sand? Means it is, other side is closed. It is not open. So in that case, can you press the sand? Is it possible?
Yes, ma'am.
Sand pressing possible. You can press a more amount of sand.
Gas or sand?
In case of sand,
Sand, no, ma'am. Gas it we can play.
gas only possible. Sand is possible.
No, ma'am.
Okay, one second. I will show you that one. In your textbook, it is given.
Ma'am?
Yes, one second, I'm showing you. Yes, what happened? Yeah, tell me.
No, nothing. I thought there's problem with my Wi-Fi. I'm not able to hear it.
No. So now you can see this piston. This is called piston. Okay. Can you see this piston? That's syringes. So the one end, this is opening, we have to close. So this we have to close, and this inside this we have to place first in one, we have to put a solid, any solid substance. You can take iron nail. Then second one, you have to take water. And third one, you have to take air, that is gas. And then try pressing. So is it possible that it can be solid? If we place a solid in it, is it possible to press?
No, ma'am.
No, not possible. That means we are not able to squeeze solid. So therefore we write property as solids are incompressible. Incompressible means they are not able to get compressed. What about water?
It will compress little.
Very little. So we can consider as 0.1%. Yes, some part in some sort way we can compress it. What about the air then?
It is highly compressible.
We can able to compress it to this much extent also. Till this much level also we are able to get compressed. So that means they are highly compressible. So we can write. So if we write here, it will become they are highly compressible. Okay. Then intermolecular force of attraction. Who will tell? Shreya? Shreya, can you tell? Intermolecular force of attraction. Shreya, can you hear?
Ma'am, solid.
Yes.
Ma'am, solid is force of attraction.
Your minimum, maximum. They have less or they are more.
Ma'am, more.
They have more force of attraction. Okay, so they have more. Fine. I will write maximum among all of them. Then what about the liquids?
Ma'am, they have less.
Less. So less means they have less than gases also?
No.
No, means how you'll write then this part? How will-
Ma'am, more than gases.
More than gases. Okay. So that means they have less intermolecular force is less than solids, but
More
greater
than
than or more than gases. Right?
Yes, ma'am.
And what about the gases?
Ma'am, it doesn't has force of attraction.
So doesn't have, no, we are not tell that is it is completely zero. It has, but very less.
It has very less of force of attraction.
So least, or we write is as negligible. Okay.
Yes,
And the next one, Tanya, intermolecular space.
and solid have less space.
The least.
Least.
Okay. Then
Liquid
liquids.
have little bit more than solid.
Okay. So we can write more than solids,
less than gases.
but less than gases. Okay. Very good.
and in gases it is most maximum.
It's a maximum space, right? So they have maximum space between the particles. Then Vedant, density. Do you know what do you mean by density? Vedant, Hemant.
Density means if we drop something in water, the number of water displaced.
No, no, that we could also
Um,
call as a density. I will tell you
Ma'am,
sections.
thickness.
Density of your classroom is 40. School classroom density of the students is 40.
Thickness.
Oh, so
No.
in solid it is most
Now, what do you mean by density first? Tell me. Then only I can explain that.
number of molecules.
So it actually, scientifically, it is the total mass present in per unit volume. So that means in a single volume, 1 unit, 1 cubic centimeter, you have taken the volume.
Hmm.
That means a container of a 1 cube container, if you have taken a cube of 1 meter.
Hmm.
Okay, in that, however, whatever the number of amount of mass present in it is called the density.
Oh,
So scientifically. So that means how in simple way, you have to check it by knowing the number of particles. The same container, how many particles are present,
hmm.
that we consider as a more or less. That way we can compare density.
Yeah, yeah.
The density is mass by volume. Mass per unit volume is called density.
Yeah, okay. So
Okay.
in
So
solid,
density is mass by volume. So mass per unit for a single volume, single centimeter cube volume, how much amount of mass is present, that is called the density. So now check out the number of particles. We can, for comparison, we are using the number of particles. So whichever have more number of particles can be present in that container, they have more density.
yeah, so it's solid.
Have maximum density because solids are compactly packed, space is very less. So more number of solid particles can be occupied, accommodated in a particular container. In the
Yeah.
same container, if you put water, then
Then it is less than solid but more than gas.
less than solid, but more than gas, right? And what about gases?
Minimum density.
Minimum, because the number of particles present in a per unit volume will be very, very less. Then Daphne, can you tell about the diffusion? Daphne, can you tell?
Possible in solids.
Not possible in solids. So it is least, we can call as. So least diffusion. Then liquids,
Possible.
possible.
It's more in
So it is more than solids, but
less than gases.
than gases, right? And then gases,
Most. It's possible.
most possible because gases are more space. Diffusion present on the space. Yesterday we have seen. So most space is present between the gases. So most amount of substances, more number of substances can easily diffuse into gases. And then kinetic energy. Trishila, can you tell kinetic energy? So what is kinetic energy first? What is the kinetic energy?
Ma'am, it is the energy which is present in.
Hmm?
No, I mean,
Yes, right. Energy.
Ma'am, it is the energy present in the particles when they're moving.
Wait, I'm asking one by one, so let them answer. Yes, Trishila.
ma'am, the energy present in solids, liquids, and gases.
No, it is not exactly that. Exactly kinetic energy, or Anurag has told that's right. So kinetic energy is the type of energy present in every object when it is moving. So whenever you start moving, you will gain kinetic energy. So any object, whenever it is in motion, It is moving, leaving its place and moving something somewhere. So in that motion, whatever the energy present in the body is called kinetic energy. Now you have to check about this motion of that. So solids are movable.
Very less.
Yeah, they can move, but they are vibrating only. So that means
Yeah.
they have less kinetic energy. So we call it as least among all three. They have least kinetic energy. What about the liquids then?
Ma'am, liquids, it is
They're
more than solids but less than gases.
Yes, right. They are more than solids, but less than gases, right? And what about the gases?
Yes. Ma'am, it is the most.
Most. So maximum kinetic energy is possessed by gases because they are randomly motion. The force of attraction to bind them is very less. So therefore they can easily move with a higher speed. So that means they possess more kinetic energy. So all these points clear to you people? Everyone, is that clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Any doubt in this part?
No, ma'am.
So this question, compare solid liquid gases by following properties. So they will give you any five properties, and you have to differentiate solid, liquid and gases. According to those five properties, question will be asked for 5 marks. Okay. So any five properties they will give you: shape, rigidity, compressibility, intermolecular force of attraction, intermolecular space, like anything they can mention. Okay, so any five will be given. You have to write the comparison. You have to always write in terms of columns. By making a table, you have to compare everything. So whenever the question is there, differentiate or compare. So always you have to make a table for it. So you have to write the properties, and as according to that properties, you have to compare the substances. So here, write it down now, this part. Just start writing. So first part here, the types of matter.
Ma'am,
Yes.
can you just scroll up
Yeah,
the first
this is a part, first part. Matter.
from
This is matter.
from
From this only you're writing. This is at the top, it is written matter. Then next part, differentiate points. These are the properties also. If they will ask you the